question 6 from the 2020 grade 12 mock exam, mainly about resistivity. And so first part A asks about this shaped object and the current flowing through it. So we have part I is asking for the length of this dimension here. So you have to imagine it as a wire traveling, going in this direction. It's a straightforward calculation using this formula from the data booklet, rearrange, substitute, and solve for 0.032 meters. That should be relatively straightforward, as is part 2, where you need to find the maximum current that can flow, so the power doesn't exceed this, so it's P equals I squared R, rearrange, and you're solving for maximum current, so 0.068 amps. Make sure you show you're working here. It's worth 2 marks. Part 3 seems to be more of a nature of science type of question, just asking why resistivity is useful. These are the 3 different answers that are in the mark scheme. I would say probably you would go to the idea of it being used in designing components and that it's useful for that, which is I've written as the middle one, but the other 2 options are also good. We move on to part B. Now this says deduce without calculation, and so there are no numbers required here. In fact, if you do a calculation, you only get 1 out of 2 according to the mark scheme. And so they really want you to use just the formula and logic to decide how the resistance changes. The change in resistance does imply that you're looking for a number, but all you need to do is use this equation, the fact that the area, when you go in this direction, the area increases and the length shrinks. That causes R to be smaller, and that's all you need to do there. And then in part C, they want you to set up a potential divider circuit that looks something like this. The idea is that this is the resistor that you're trying to measure. So 1 mark is for showing a voltmeter in parallel and an ammeter in series, and the 2nd mark is for showing this configuration of the potential divider so that you could vary the potential difference across the resistor.